this video I am going to discuss regarding the multiples. If we multiply two numbers, for example I am multiplying 2 and 3. If we multiply two numbers, we are getting answer. If I multiply 5 times 4, we are getting 20. We are getting answer. All these answers are multiples of something. That means if I multiply 4 and 5, you are getting 20. Multiply 2 and 3, you are getting 6. All the tables what we learn are multiples of something. That is the something regarding the definition of multiples. If you multiply something, you will get an answer. That answer is a multiple. Is a multiple. 20 is also multiple. That means all the tables. We learned 2 table, 3 table, 4 table, 2 times 100. It is not in the table, but it is also we can multiply it. We are getting 200. 200 is a multiple of 2. 3 times 50, we are getting 45. 45 is a multiple of 3. 4 times 5. 5 is 20. 20 is a multiple of 20 is a multiple. 45 is a multiple. The multiples of 4 and 5, 3 and 50, 2 and 20. These are called multiples. So whatever things we learn in tables, so they are multiples. All the tables what we learn, 2 table, 3 table, 4 table, 5 table, 6 table, 7 table, 8 table, 9 table, and all the tables. As well as multiples are not going to be end. Means you can take 2 times 135. It's getting 270. 217 is a multiple. It's a multiple. That means 2 table you can take many 2, 4, 6, 8, 10, 12, 14, like that. It's not going to be end. So it has a start, but it's not going to be end. It's going to until infinity. It's not going to be end. There are infinite number of multiples of any tables. Any tables has an infinite number of multiples. As well as multiples can be even positive or negative. They even can be positive number as well as they can be even negative numbers. 3 times minus 2 is equal minus 6. Minus 6 is a multiple of 3. Multiples of 3. We want to multiply all these with an integer. That means it can be a positive one, it can be a positive one, or it can be a negative one. But it cannot be a fraction. It must be multiplied with a whole number, integer. That means it can be positive or negative. All the multiples are infinite. They are going to infinite number of multiples of a number, as well as they are not going to be end. They also can be either positive or negative. It's very important. Sometimes you may think they are limited. No, they are not limited. They are infinite. They are not going to be n. Not going to be n. There are many multiples. They are not going to be n. They are infinite number of multiples. These things we have learned. All the tables we have learned. So we know that there are many multiples. As well as multiples can be either positive or negative. Next, move to the next one. Next is we can mark the multiples of a grid. For example, if I want to mark the multiples of 3, I start with first it's 3. Next is 6. Next is 9. This is the 3 table. Next is 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42 and many more. That means all the multiples are there, but it is not going to be n. It is moving. It's not going to be n. If I want to multiples of 5, I can mark 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, like that we can mark. All the multiples we can mark on the grid. That means they are not ending. They are not ending. They are moving forward till infinity. That's very important. Next we go to the next slide. Next slide is how we find the multiples and how we find something common for them. For example, now previously I got only one table. Now I am taking about two tables. For example, I am writing the two table here. Multiples of 2. 2, 4, 6, 8, 10, 12, 14, 16, and dot. Next I am writing the multiples of 3. 3, 6, 9, 12, 15, 18, 21, 24, and like that. Now I am going to mark something common for them. So I want to go for the big number. This is the big number. 3 is the big number. When I compare with 2 and 3, 3 is the big number. I am checking the numbers from big number. 3 is there. Is it 3 here? No. 6 is here. 6 is 60. Yes, it is also here. You also have underline, and I circled it. So it is common for 2 and 3. It is a common multiple. Next I am forward. 9 is not there. 12 is here, and 12 is also there. Here is there. 12 is common. 12 is common for both. Again it's coming. 18 is also there. So what are the common multiples for 2 and 3? Common multiples for 2 and 3, there are 6, 12, 18. So can we? Yes, of course. Next one is 24. Why? It is on the 6th table. This one is 6th table. 6th table. So common multiples are also not going to be in. They are not going to be in. They are also endless. They are also moving further until infinite. There are infinite number of common multiples. So that means we don't have a highest value. We only have the smallest one. That smallest one. What is the smallest value for here? The smallest one is 6. 6 is the smallest common multiple. Otherwise we can say least common multiple. I guess this one. So we can say M. Least common multiple. That's a least value. LCM. Here we don't have a highest value. Why? Multiples are not going to be in. They are going to be infinite number of multiples are there. So they are not going to be in. We have only the least value. That's called LCM. First of all, we want to mark the multiples. All the multiples we have to write. If we are comparing two numbers, we won't write the multiples of these two numbers here. 4, 8, 12, 16, 20, 21, like that we want to mark. Next number is 5. Multiples of 5, 5, 10, 15, 20, like that we are marking. Next, go for the big number. Here big number is 5. 5 is the big number. Go for 1 by 1. 5 is here, 5 is not there. 10 is here, 10 is not there. 15 is here, 15 is not there. 20 is here as well as 20 is here. That is how we can find the common multiples. After that we are finding, okay, there are many number of common multiples. 20, 40, 60, it is on the 20 table. 80, so it is not going to be end, so we have only least value. Least value is 20. That's we are calling LCM. LCM of 4 and 5. LCM of 4 and 5 is 20. 20 is the LCM of 4 and 5. So this is one method of finding LCM. You want to mark the multiples and find the common one, then find the least value. That least value we are calling as LCM. After we find it, we can mark it on different ways. If we are marking the tables, we can mark them and join them. This is 12 and this is 12. These two 12s are joining each other. Next is coming for 24. 24 is here, 24 is here. 24s are joining together. These are common for them. This is very important. This is called least one, LCM. We can mark the tables and join them. Otherwise, we can mark it on another diagram. We mark the circles, multiples of 3, all the multiples of 3 are here. All the multiples of 4 are also here, separately. But something at center that is common for both. Something at center is common for both. That is common for both. Whatever other multiples of 3, for example, multiples of 3 are 3, 6, 9, 12. 12 is coming to the center. Why? It is common. Next is coming 24. 24 is also coming to the center. Next one is 12, 24. Next is 36. Why? It is on the 12 table. 12 table. It is on 12 table. So 36 also there. Whatever things remaining on the 3, that is only multiples of 3. 3 we have to take it. 6 we have to take it. 9 we have to 3, 6 and 9. Next 12 is already common. Next is 15, 18, 21. 15, 18, 21. Next is going like that. For the 4 is not common for both. It is only multiple of 4. That is coming for the 4. I mark it 4 here. 8 is also here. 12 is common. We already have taken this 12. 12 is already we have taken. 12 we already have taken. So it is common for them. Next we want to go for the next one. 16. No, it's not common. It's only for multiples of 4. Like that we can mark the multiples and represent this on a diagram. If someone is asked to mark on a diagram, this is the two ways we can mark. We can mark it on the tables and join them and mark it on the diagram. Next we are going for the next. Is there any other way to find the LCM of number? For example, previously we got, I will take two numbers. I am taking 2 and 3, multiples of 2, multiples of 3. Multiples of 2 are 2, 4, 6, 8, 10 and like that. Multiples of 3, 3, 6, 9, 12, 15 and which one is the least one? That is, I am going for the big one, big number. 3 is here, 3 is not there. 6 is here, 6 is there. 6 is here and 6 is there. 6 is the LCM. LCM. Is there any other method to find this LCM? Of course there are. We are marking the numbers. We want to divide them by prime numbers. Prime numbers. I am starting. What are the first few prime numbers? 2, 3, 5, 7, like that. First few numbers I got here. First I am checking whether these two numbers are divisible by, these are prime numbers. Prime numbers. These two numbers are divisible? No, only 2 is divisible. I am taking 2. 2 divided by 2 is 1. This is not divisible. This I am taking, keeping at same. This. Next I am taking 3. This is already 1. This is already 1. Now we are taking 2 times 3. We are taking 6. That is how we get 6. If I go for 24 and 36, 24 and 36, I got the prime numbers 2, 3, 4 and 7. Like that we can take more and more and more. First I am taking this 24 and 36. Is they divisible by 2? If it is divisible, we have to divide it. Of course it is divisible. That means 24 is also divisible by 24. 24, I'll write down 24 here, is ending with 4. Ending with 4 means it is divisible by 2. 36. 36 also divisible by 3. Why? It is also ending with 2. It's also divisible by, so I divide this number by 2. 36. 24 divided by 2 is 12. 12. 36 divided by is 18. I get 18. Again I am checking 12 and 18. They are also divisible by 2. Divisible by 2. I am dividing out 12. 12 divided by 6. 18 is 9. Now I am checking whether these two are divisible by any common from here. No, I don't find anything. That means 6 is divisible by 2, but 9 is not divisible by 2. 6 is divisible by 3. 9 is also divisible by that. If you like, we can do it this way. I will divide this thing. I will do it this way. I am writing now 24 and 36. I am dividing it by 2. It's getting 12. It's getting 36. Yes, okay. Next, it is common for 2. It's also dividing it again. It's getting 6. It's getting 9. Now I can see that these two numbers is divisible by 3. Of course I can get 3 here. If I get 3 here, it's getting 2. Here it's getting 3. Now I am checking. Is there any prime number that divisible both? No. I am going for the smallest one. I am going for the 2 now. So this one is 1. This one is remaining same. Next I want to go for the 3. It's 1 and 1. What are the things? If I multiply 2 and 2 and 3 and 2 and 3, you are getting the common multiple for these. Common multiples for 24 and 36. That is 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. 24 you want to multiply by 3. You are getting 4 times 3 is 12. 1 is there. 6. 72. It's getting 72. 72 is the answer. If you multiply all these 3, you are getting 72. 72 is the LCM. LCM. LCM, least common multiple of 24 and 36. Why do we need to find LCM? Actually, it is very important in different ways. Some practical questions also there. If we want to do the fraction problem, it is very important to know the LCM. Let's see now. If I want to add or subtract fraction, I will take 2 upon 6 and 5 upon 8. 5 upon 8. So I want to convert them into the common denominator. I want to convert them. 6 and 8 is there. 6 and 8. I want to multiply this number by something. This number by something to get something common for them. Then I can add it. That's the way. So that means I want to get something multiples of this. Multiples of this, as well as they should be common. These two are getting common. Same. These two are getting same. Here's the example. That means if here I want to get a multiple of something, multiple of 6, multiple of 8. These should be equals. These should be same. Should be common. That is LCM. Least value. I am going to take the LCM of this one now. I am dividing it by first. What are the prime numbers I can take? 2, 3, 5, 7. Is it divisible by 2? Yes, I am taking 2. Next, I am dividing it, getting 3 and 4. Next, again I am dividing. Is it divisible by both number divisible? No, it's not getting. Next, I am getting something. Yes, this one I take 2 I can get. Why is 2 is there? Is 3 is 2. Again, which one is the smallest one? 2 is also can get. Yes, 3, yes, 1. Next, yes, I just have 3, 1 and 1. What's the LCM? 2 times 2 times 2 times 3. 2 times 2 is 4, is 8. 8 times 3 is 24. 24 is the LCM. That means you want to, if you come to here, that's common for these two. These two are is 24. 24. That's the least value you can get for this one. Next you can get for the 24 times 2 even. Even for the 48, it is also common. Next is you can get even 24, 48 and many down. But this is the least one. Least one we have to take. Why? It is very easy to do the work. Now I want to convert this one into 24. What I have to do? 24 is 6 times what? 6 times. Where I can get 6? Here it's getting 6. 6 times 4. Here it's getting 4. 6 is already there. That is 2 times 3 is 6. Next one is 2 times 2 is 4. That means you want to multiply this one by 4. This one by 4. Next 8 you want to take. 8 is coming on this way. I will take another color and mark it. 8 is coming on this way. This is 8. 2 times 2 times 2 is 8. What is remaining? 3 is remaining. That means you want to multiply this one by 3. By 3. So bottom denominator you are getting 24. You also getting 24 now. 24. Next numerator is getting 8 here. Numerator is getting 15. Now we can easily add why they have common denominator. They have the common, that is also least value. Otherwise we can get something bigger than that one. That's not good. Okay. So we have to take the common denominator and add them. 8 and 15. 15. We can add it easily by getting 24 as the denominator. It's getting 23. 23. So this is the some usage of LCM. Is that all? No. Actually, there are some practical problems practical things we can explain using LCM. For example, I'll take something like this. When I go to the office, on each and every, after each and every 2 days, I am wearing my watch. Each and every 3 days, I am wearing my hat. Each and every 3 days, I am wearing my watch. This is my watch. I am wearing it. This is my hat. I am wearing my hat. Wearing my hat. So this is the number line. Start with 0. Each and every 2. That means 2 skipping. First skipping is 2. Second one is 4. Third one is 6. 8. 10. 12. 14. Like that I am wearing my watch. Next. Each and every 3 days I am wearing my hat. Started from this day 3. I am jumping to here. This is 3. Next I am jumping to 3. Next is 6. Jumping to 6. 6 is here already. That means on this day I am wearing watch and hat. Again, next is coming to the 9. 3, 6, 9. This is 3. This is another 3. 3, 6, 9. 9 is coming between. Next is 12. 12 is that means even at 12 from today, after 12 days I am also wearing watch and hat. This is some kind of a practical action, practical things I can find. Another example. My small child is going out with me. When I keep 1 step, he have to keep 3 steps. You have to keep 3 steps. You have to keep 1, 2 and 3. When I keep, he's like that. I have to go. If I make 3 steps, he is coming again to me. He is coming again to me. I am like this. I am walking like this. This is also something LCM. Second, my it is also small steps, 1 2 3, again 1 2 3, like that. That means I am putting 1, second one is 2, third one is 3, fourth one is 4. He is putting first 1 2 3 4 5 6, and like that he is putting steps. But after 3 he is coming to me. That means he is counting with the 3 table. He is counting with the 3 table. He is going with 3 table. What's 3 table? 3. Next is 6. Next is 9. Next is 12. Like that he is keeping. That means these are the places both we are coming together. Both we are coming to. Next he is coming to the sixth one. Next 9 1. Like that is we are taking. That means, and some places we are joining together. That is common for both. Common for both. These are the some practical equation that comes with the LCM. Multiples are very, very important. When we go for the first one, something like this. Go to the first slide and I will come back a little bit. Multiples are the something we can get by multiplying two numbers. Multiples are infinite. It can be 2 table, 3 table, 4 table, 5 tables. All the tables are multiples. We have to multiply a number with the integer. Integers are positive or negative. That multiples are also positive and negative. They have positive or negative values. They have infinite numbers. That means we don't have an end. We don't have end. We can't put an end. So it is endless. Endless. It's not going to be end. Infinite number of multiples are there. Next, if we are taking the two numbers together or few numbers together, there may be something common. I am marking at something here. This is 3. We'll mark it and color it. This is 3. This is 6. This is 9, 12, 15, like that. 5 table is also coming like that. So someone are common here. This 15 and 15 is common for them. Is there anything? No, 5 is not common. 10 is not common. Like that we can find. Next is coming. Like that we can find something common for them. It's coming with the 15 table. Next is 30. Next is 45. Next is 60. It is coming with the 15 table. So something common. If we are taking 2 or more multiples, something may be common. It's very important to find. We are write down the multiples of them and take the biggest number. From that one we are starting. 5 here, 5 is not there. Like that we are starting. And after that something common for them we are marking. Common for them we are marking. We are write down that. That is also not going to be n. They also have many numbers. The first one is called LCM. Why? It is the least value. We don't have last. We don't have the biggest value. We don't have biggest value. It's going to be infinite. So least value is there. That is called LCM. That is how we can mark the LCM. Next, we can represent it in different ways. We can mark it on the tables and joining them, and as well as we can mark it on a diagram. And something common is coming for here. If we have 3 numbers, we can mark it on the 3 circles. 3 circles. 3 circles. If there are 3 numbers, all the common things are coming to the center. Like that. It's a one way of representing multiples. Next, we discussed regarding, is there any other way to find the LCM? Yes, that is simplest way is marking on and mark them and divide them with the prime numbers. All these numbers should be prime. We can't divide something else. We want to divide it by prime numbers. Prime numbers. We have to remember the first few prime numbers, then we can divide it, and finally we want to find it to 1 and 1. If we multiply all these things, we are getting common multiples. After that we discuss something, practical examples and something. It is very important in fraction. it is coming with fraction. When we are doing the fraction, we are learning this one, fraction. So we need, if we have the different denominator, we want to find something common for them. That is called LCM. LCM is the least one, is the simplest one we can do. But like that we can add, subtract fractions. That's very very important to know when we learn the fraction. Lastly, we discuss something, practical question. Practically, this is very commonly happening. Some events we are doing, but some events are coming together. Some events we are doing day to day. If we are doing many events, some days are coming, we are doing more than one event. For example, here I am wearing watch, I am wearing hat. On 6th I am wearing both. On 12th I am wearing both. Like that, practical questions also there. So I think you got some regarding the multiples. Thank you for watching the video.